reagents or chemical grade. It can be used in all scientific areas where quality is critical. Okay, take note of this class sa mga research, you use this one. Quantitative analysis in quality assurance environments, no? Especially if someday na-employ ka mo sa quality control labs, no? Dapat amo gini ang chemical grade. Research labs also producing primary standards. You will understand what primary standards better as we go along. Another grade, we have the USP grade. Yeah, this one. So diphenyl hydramine hydrochloride, USP. What is it? It meets or exceeds requirements of the United States Pharmacopoeia or the USP. This grade is acceptable for food, drug, or medicinal use. It is also used for most lab purposes, but the USP being followed should always be reviewed prior to beginning to ensure the grade is appropriate for that methodology. So, ini siya, nga grade. If you have options, mas mayo nga mo ning gamiton yun sa anal chem. Although it is accepted for food or drug, pero when it comes to research, mas mayo ang AR. Okay. Next, we have the NF grade. NF means National Formulary. It meets or exceeds requirements of the National Formulary or the NF. The USP and the NF jointly publish a book of public pharmacopoeial standards for chemicals and biological substances. So this is also somehow similar to the USP grade. Okay, it's used for compounded preparations, medical devices, and dietary supplements. So NF products. Okay, next grade, we have the lab grade. This is the most popular grade for use, take note, educational applications, not for research or scientific experiments or for doing analytical works. Okay, this is only used in educational applications, so lab grade. But its exact levels of impurities are unknown. That's why you cannot use this in testing, for example, for quantitative testing of analytes like nitrites or ammonia. No, you cannot use this one because the impurities are unknown. It might contain some impurities that can add to your reading. Nagtaas pagad ang mo na ammonia or nitrite. And is not pure enough to be offered for food, drug, or medicinal use of any kind. So, abin nga ni class, pag hambal laboratory grade, you can use it in the lab. No, be familiar with the different grades of chemicals and its specific use. Okay, so what are the alternate names? We have laboratory reagent, LR, or chemically pure. It's equivalent to lab grade. Next, purity level, relatively high purity, but the exact levels of impurities are unknown. It meets the USP standard. Certification needs to be checked if suitable for use in other applications. So, it is excellent for teaching and for educational labs sa mga schools, but not pure enough for food, drug, or medicinal use. It's often used for general lab work where an analytical reagent is not required. So with this statement, hindi na siya pwede sa service lab, no? Nga kinahanglan ang accuracy sang test. Okay, so this is only for general use, no? For teaching, no? In educational labs. Next, we have the technical grade. This one. So it's only 15%, volume by volume, ang hydrochloric acid. It is labeled as technical grade. Okay, so this is used for commercial and industrial purposes, mga cleaning reagents. No, those are technical grade chemicals. So on alternate names, we have tech grade or TG or commercial grade. So take note of this class kay sometimes no sa board exam like for example TC grade is also so pangita mo the A B C D mo na ba, so just be familiar with it and its alternate names. Okay, this is not pure enough to be offered for food, drug, or medicinal use of any kind. So what about the purity level? It contains impurities. Basic product specs usually available, no? Because it states here 15% only, no? Sometimes complies with food grade specification, but when it comes to food grade, ginabutang yun na siya nga food grade. So applications used in low grade applications or qualitative testing. So hindi siya pwede sa quantitative. Often used in bulk for industrial or commercial applications because, like for example, the hydrochloric acid, which is 15%, is also a cleaning material, cleaning reagent. Okay, 6, nauna ang 7. 6, purified grade, also called as pure or practical grade, meets no official standard, not pure enough to be offered for food, drug, or medicinal use of any kind. Next, there are also other grades, no, other than the 7 common grades. These grades are application specific, meaning may purpose sila nga hindi siya pwede magamit sa iban or kinahanglan amo gina siyang gamiton mo for a specific use. Okay, these grades are application specific. Extensive data is available from manufacturers and distributor. Example, the ones used in HPLC, no, test or analysis. So HPLC means high performance liquid chromatography. May ara na class nga example acetonitrile, may ara na siya yung HPLC grade nga hindi mo magamit ang iban nga acetonitrile HPLC grade lang gad ang pwede magamit for HPLC use or chromatography use. Next, for the water, dapat ultra pure. Kaya di ba ang HPLC is a high priced instrument, yung isa ka unit na cost around 3.5 million pesos. So kung ang gamiton yun ang chemical is not the grade nga specific lang for use sa HPLC, basta maguba ang inyo na line system kada mo impurities masulod. And also the water used there advisable quality, the advised quality is the ultra pure water. Next, AAS, ICP, you know the meaning of this one. Atomic absorption, spectrophotometer / inductively coupled plasma standards. So may ara man siya nga set of standards. No? It's only for AAS and ICP use. Next, it also needs ultra pure water. Next, familiar ka mo with molecular laboratories. Ang chemicals nila are molecular biology grade. So, like it also needs ultra pure water, no, as one of the supplies. Okay, and also there are reference standards, no, for other tests. Reference standards, we will discuss this kung ano na sila later, no? Then food pharmaceutical grades. Food grade, okay. Now, to goes with the chemical upon delivery, may ara na dapat sang certificate of analysis, no? Kung ano da ang compound, kung ano na siya ang composition sang compound. Ikaw kami kasunod. Ganyan. Okay, so this is how the certificate looks like. Kada delivers ng sang chemical, pangitaan yung gid sang certificate of analysis stating purity, mass, concentration. So in here, we have here purity. Hindi ko mabasa. Performed by HPLC must be represent on the HPLC grade. Okay. Now, other important terms, we have the guaranteed reagent, GR, suitable for use in anal chem, so pwede siya sa analytical labs, products meet or exceeds ACS, so equivalent siya sa AR grade, no? This is guaranteed reagent. Parang AR, the standard Mallinckrodt grade of analytical reagents. Suitable for lab and general use. If the reagents also meets the requirement of the ACS, it will be denoted as AR, ACS reagents. So meaning, this can be used in analytical testing. Now we go to standards. Ato kaginang ginahambal ko no, primary standard, here it is. So primary standard is an analytical reagent. Ano gani ang analytical reagent? AR grade, no? Of exceptional purity that is specially manufactured for standardizing volumetric solutions and preparing reference standards. Diba? Familiar ka mo sa acid-base titration? Gagamit na ang example 0.1 sulfuric acid as against 0.1 sodium hydroxide. So ina siya ang is either sodium hydroxide or sulfuric acid, gina-standardize na siya to know kung ano gina ang concentration niya para magamit yun sa equation when checking on the concentration of your titrant. Next, organic reagents, OR, are suitable for research as applications. Then another one, practical, no, defines chemicals of good quality where there are no official standards. Okay, so practical grade, organic chemicals may contain small amounts of isomers of intermediates. Okay, so now going back to primary standard. It is a reference chemical used to measure an unknown concentration of another known chemical. Paano ko na ma-explain ka? So example, if ang procedure niyo sa acid-base titration, familiar ka mo class sa acid-base titration? Anybody? Please answer para mabalaan ko kung i-explain ko pa. Anna, are you familiar? Who else? Jane Laarne. Ang wala ka sa bat absent?
Hindi masyado, miss.
You state your name, please. Si Jane?
Ana.
Ana. Okay, okay. So, present ka. Okay. It's okay. At least I know. So, ang acid-base titration, di ba? Acid as against base. So, dapat ang inyo na siya nga titrant, amo na siya ang solusyon, yung ginagamit to titrate an unknown substance or unknown solution. So, ang titrant yun na, amo na siya ang known niya, diba? Amo na siya ang known. Galing kay, during preparation, hindi ka mo kabalo kung ano gina siya ang exact na concentration. Pero when the procedure says 0.1 normal sulfuric acid, tapos nagtimpla ka man 0.1 normal, but you are not so confident kung 0.1 gina siya, basta 0.099 or 0.095, mga mo na bala. So, how do you know na dapat kung ano gina siya ang concentration na niya, which is known, di ba? Kasi procedure says it's 0.1. But to be exact, hindi ka, you don't have a way of knowing kung ang 0.1 mo is really 0.1. No, kaya di ba may factor ka nga ba si ang acid mo tahaw, no? Or basi ang sa imo na measurements, no? Instead of using volumetric glassware para ma-make into volume mo na ang imo nga solution nga 0.1 is ang naghambalbi ang procedure nga dilute this amount of acid to 100 ml. So, equivalent ay siya sa 0.1. Ang gingamit mo ya is Erlenmeyer flask. Kaya wala ka sa volumetric flask na dapat amo na gamiton. So, you are not certain if your concentration is really 0.1, although it's close to 0.1, okay? So, you need a primary standard. Now, it will serve as a reference chemical, no, used to measure the unknown concentration of another known chemical. So, ang example today is 0.1 normal sulfuric acid. It is unknown, but you are not certain kung 0.1 gina siya. That's why it is an unknown concentration of a known chemical. Okay? So, nakuha nyo na. So, we need a primary standard. It is used directly when performing titrations or used to calibrate standard solutions. Kay known siya mo. Next, it exhibit distinctive characteristics that ideally suit them for making accurate, take note ha, primary standard, dapat accurate and reliable assessments of the concentration without the need for specialized equipment. So, how can a chemical be qualified as a primary standard? So, you note out the following characteristics. Okay? It must be high purity. So, nakapasar to kagina ang ACS grade, ang AR grade, ano pa itong grade, di ba? As one of these parameter, no, high purity. Next, low reactivity dapat ang chemical with air or surrounding environment. So, dapat pag na-expose sa air, hindi siya mag-react. Stable siya, in other words. And low hygrospicity, meaning, hindi siya makakuha water from the air. No, hindi siya lang mga hygroscopic, di ba? Sodium hydroxide, kung expose mo na siya dugay, nag-melt siya, ano siya, water. Kuha. Next, should have a large molar mass. Dapat high molecular weight ang chemical to pass as a primary standard. And it has a predictable reactivity. And also, it must be cheap and available sa lab. Okay, so a primary standard is a chemical that is of the highest purity and can be measured directly to produce a substance of exact known concentration. Ang requirements ng IUPAC, International Union of Pure and Applied Chemistry, requires the primary standard or the PS must be at least 99.98% pure. No, and the working standards be 99.95% pure. So ang primary standard class, anyway, you will understand better as I have said as we go along. Ang primary standard na siya, kung nagagamit ka sa spectrophotometer paged, aside from titration, kagina titration ng aton sample. Example, I mean. So, kung nagagamit kaya sa mga spectrophotometers, and you need also a primary standard para maghimo sa imo working standards para maghimo sa calibration graph. So, ang calibration graph nyo is concentration against the absorbance of the equipment. Okay, kung may ara na kung the equation of the line, nag-straight line, di ang inyo nga concentration, different concentration, ma-solve nyo na dayon ang inyo nga unknown concentration sa sample. So anyway, intindihan nyo na in the next nga meetings. Okay, so here. For acid-base titration in volumetric analysis, no? Here, we have here potassium acid phthalate as your primary standard, di ba? High molecular weight, if you could remember, dapat ang primary standard, high molecular weight, what else? High purity, stable, hindi siya hygroscopic, what else? Low reactivity. And must be cheap, barato, kag ara sa lab available also. So in volumetric analysis, sa inyong mga titration, bala nga mga experiments or titrimetric analysis, you have here potassium acid phthalate. Ang secondary na siya, ang gina-standardize nyo are sodium hydroxide or potassium hydroxide. Next, we have here benzoic acid, sodium carbonate. Okay, secondary standards are sulfamic acid. Okay, so fourth. Now for this one, this table, we have here again sodium carbonate sa acid-base titration. Siya ang uses niya as primary standard. Purity should be 99.9%. So dapat AR grade siya, no? Next, gram molar mass is 105.99. So taas siya molecular weight. And so with potassium dihydrogen phthalate, na gina-use naman na siya in bases. Next, potassium dichromate, high molecular weight. It is used in standardizing reducing agents, usually some mga redox titration, and also with potassium iodate. So it is used to standardize sodium thiosulfate also in redox titration. And example, so okay, pag volumetric measurements or analysis, di ba may aratan na sang indicators, no? High titration mo. So, in here sa acid bases, we usually use phenolphthalein, methyl arenes, remember nyo na. Then for redox reactions, we use starch. And for analysis of chlorides, no, your primary standard is sodium chloride. Used is for standardizing silver nitrate solution, which is your titrant kung mag-analyze ka mo sa chlorides in water and also in food. Okay. Now, this one is EDTA, disodium dihydrate salt, as your primary standard. Take note, ang purity nila tanan tag 99.9%, no, ang grade. Next, this is used in metal salts, no. Example, calcium in water, total hardness in water, diba? EDTA ang ginagamit ta. Okay. Okay, so pure standard. Okay, the purity of the primary standard must be very high, as impurities in the preparation could alter the stoichiometric point of the reaction. So dapat tanan nga primary standard must be of high purity, no? Parehas ni 99.9%. Okay. Should not be reactive with or take in moisture from the surrounding air, as this would also alter the stoichiometric point of the reaction. All of these are not hygroscopic, no? They are stable. What else? Chemicals used as primary standards naturally exhibit low reactivity with air and low hygroscopicity or ability to attract and absorb moisture from the air. So what happened kung ang imong primary standard nga gingamit na na hygroscopic, no? You would generate erroneous result. Kaya diba, dapat wala siya sang reaction, low reactivity siya with air. So, hindi na to amo ang result niyo. Kaya may, may interference na siya sa moisture and na-alter na ang stoichiometric point of the reaction. So, that's the reason why ginunata learn ang different uh, uh, types of chemicals before anything else. Okay, standard property should also have high molar masses that allow them to be easily accurately weighed on a balance with minimal error. So if you would notice the procedure, especially sa mga standard methods, ang ilang primary standard usually is 0.1, weigh 0.1789 gram of potassium dihydrogen phthalate, weigh 0.2501, maamo na bala. Kay dapat high molar masses so that ang weighing niya could be sensitive up to the 0.1 milligram nga so it would mean also it's more accurate, no, with minimal error. This property facilitates accurate calculation of the molar concentration of solutions when they are prepared in, take note, volumetric plus ha, basta mag-prepare ka mo standard solutions with different concentrations, be it a primary or a working standard, always use volumetric plus. If the procedure says 25 ml of 0.1 molar potassium dihydrogen phthalate, so you should have 25 ml volumetric plus, not 25 ml Erlenmeyer plus, because they are not volumetric apparatus. Dapat plus, vol plus. Kag gina-calibrate man ni siya, ha? Okay. The standard should be inexpensive, commonly available. So, di ba, usually, may ara, maganda sa lab, sodium carbonate, no, potassium dihydrogen phosphate, no, ara, ganun na siya. And should be non-toxic. Sorry. And soluble in water or other common solvents. These properties are not necessary, but they do make standards easier and safer to work in the lab, no? Non-toxic, insoluble in water or in other solvents. Okay. Now, for the measurement standards, they are classified into 4. We have the international standards, the primary standards, the secondary standards, and lastly, the working standards. What are international standards? They are defined by international agreement and are maintained at the International Bureau of Weight and Measure in France. So one best example is the set of weights, diba? May ginang reference set of weights, the mother of all the set of weights. So they are maintained, no, at the International Bureau. So amo gani siya ang pinaka-reference of all the weight, example na set of weights. So diri na siya sa maklasify sa international standards. These are as accurate as it is scientifically possible to achieve. They may be used for comparison with primary standard but otherwise unavailable for any application. So, ang ato ng mga primary standards are, these are commercially available chemicals, but during manufacturing of this primary standard, it is based on the international standard. That's why international standard first, then second is the primary standard. Next, we have the primary standards, no? Kaya una-una, pinakataas ng international standards, then we have the primary standards. And this, by definition, by the International Union of Pure and Applied Chemists, 1978, primary standards is a substance of high purity, which by stoichiometric reaction is used to establish the reacting strength of a titrant, of which itself can be used to prepare a titrant solution of accurately known concentration. Okay, so the requirements are, as we have discussed, high purity, 99.9% or even better. But it's hard, though wala man kung may nakakita pa so far na 100%. Usually it's 99.9%. Next, again, stable in air, absence of hydrate water. So class, kung may nakita ka mo sa formula ng example lang, sodium thiosulfate, dihydrate or trihydrate or tetrahydrate, and then na siya pwede for use kaya dapat the absence of hydrate water. So dapat it's really wala water ang formula. Next, readily available, reasonable ang iyang solubility, and also has large formula weight. And there are three types of primary standards. So first, we have the reference material. This is only used for calibration. Ginabakal ni siya. This is commercially available. And the high purity standard or the chemical standard. And next, we have the certified reference material or the CRM. So makita nyo na sa mas ma-meet yung mga words nga RM, no, it's reference material. CRM is certified reference material. Okay, so okay na tas sa primary standard, then we go to secondary standards. Okay, there are few compounds that meet this criteria. So often a less pure compound has to be used as secondary standard. Okay, the ideal standard solution should be sufficiently stable that its concentration needs to be determined only once. Should react rapidly with the analyte. You know, class, what an analyte is? Example, ang inyong gusto nyo mabalaan kung pila, ginailonggo ko na nakay para kay Shindig. Gusto nyo mabalaan kung ano ang calcium contents ng water. So, ang inyong analyte is calcium, meaning it's the object or the compound of interest. Damo-damo na siya composition, ang solution may magnesium, but ang inyong object or ang substance of interest or ang element of interest is calcium. So, calcium is your analyte. Muna. Tapos, muna. Ang inyo naman like for example, your sample is water. Ara na embed ang analyte. So, your water is your matrix. It is the ang dog carry sa analyte niyo. So, matrix, ang term. So, analyte, hindi na kamo. In determination of ammonia in soil. So, your analyte is ammonia, your compound of interest, okay? And your soil is your sample, which is also your matrix. Okay. Next, going back, ideal standard solution should react more or less completely with the analyte for good endpoints. This is in reference to titrymetric analysis methods. Undergo selective reaction with simple balance equation. So meaning there should be a balanced stoichiometric reaction. Okay, few reagents meet all of these requirements. Okay, so let's differentiate now the primary standard and the secondary standard. Okay, primary standard are the compounds having reagent, meaning kung ano gina-analyze niyo, like phosphate ang inyong analyte, dapat ang inyong primary standard should contain also phosphorus or phosphate. So in the analysis of phosphate in water, ang inyong primary standard should be nakapasar to sa requirements ng primary standard and should have your phosphate as the analyte nga dapat ara man na sa formula sa chemical composition sa primary standard. So one example is potassium dihydrogen phosphate. Kaya di ba may phosphate siya, may phosphorus, no? No, standards are compounds having reagent analyte, no, as of high purity. So your analyte is phosphate, kaya mo na gusto nyo mabalaan sa water, then you will use a primary standards which contain also phosphates, and that is potassium dihydrogen phosphate. Okay, so this can directly be used for preparation of standard solutions. Now, what about the secondary standards? They are analyzed against the primary standard solution. Basically, these are prepared in the lab for specific analysis. So one example is that if your primary standard is, if you're doing acid-base titration and your titrant or your standard solution is sulfuric acid, which is zero 0.2 normal, it should be standardized against a primary standard, which is sodium carbonate. So in this case, ang sulfuric acid nyo is your titrant, no? Amo na siya ang inyong against, standardizes against the primary standard. Tapos, nahimo na siya nga secondary standard na ang acid, ang sulfuric. Then, you can titrate it again with sodium hydroxide kung gusto nyo anong ang mabalaan ang concentration sa inyong unknown solution nga containing sodium hydroxide. Next, one example again here. Sodium chloride is primary standard for silver nitrate. Sodium hydroxide is primary standard for HCl. Sodium hydroxide solution. Okay, so this one naman, ang secondary standard could be also sulfuric acid or sodium hydroxide. No? Basta pag sodium hydroxide, it could be, so ang iyang acid is sulfuric acid, which is standardized against sodium carbonate. So anyway, sa actual, ma-learn nyo na sa lab, kay kabudlay mag-explain sa wala nyo nakita. So we also have acid-base titration as part of the lab activity. I-explain sa inyo. Okay? Just be familiar first with the terms. So primary standards also are used to prepare solutions which are necessary for the calibration of analytical instruments. So example for pH meters, diba? You need buffer solutions, pH 4, pH 7, pH 10. No? Those are examples of standard. Okay. So another comparison. Okay, so here again, we all have mentioned this one, no? Easily obtained with very high grade of purity, non-hygroscopic, must have high equivalent weight to minimize weighing error, and must react with other substances in quantitative way according to balanced chemical equation. So that's stoichiometry. Now, what about the secondary? The concentration of which can be directly calculated from the weight of the solute and the volume of the solution. That's why you have to titrate it, or is in this case titration, against a primary standard solution para mabalaan mo ang iyang nga exact concentration. Sang secondary standard needs a primary standard solution. Now, ang working standards naman are the principal tools of a measurement lab. They are used to check a calibrated general equipment for accuracy and performance to perform comparison measurements. No? Okay. So one example is ang primary standards mo. Pwede ni siya mahimo working standards. Gaanta na ako mo example para hindi ka mo ma-confuse.
Yan. So, napayos na itas, nagpapapalitan sa bugos, no? Tapos sa dalawang atong paano, tapos ko may gas kung nakabilin itulong kung hindi na puti. Narilyo, dahil na mo paano na submerge mo sa anong feeling ko lang din.
Makita nyo ang graph, class? Makita nyo? Can you see the figure and also the data?
Yes, Miss.
So, ang kinahambal ko kaginahilongguhon ko na lang yun. Ang primary standard is, example, kay ginapang, ang aton diri is ang phosphate sa water ang ginapangitata. So, dapat, ang primary standard niyo should also contain phosphate. So, what is the best nga chemical in the lab nga may ara sina which can fit sa requirements ng primary standard? So, we have here potassium dihydrogen phosphate. Okay. Nalipat ko galing sa weighing. Basta it's 0.2, basta 4 digits na decimal digits na mag-weigh to make a solution of 100 ppm, I think. After that, from the 100 ppm, matimpla ka sa intermediate nga 10 ppm. Kay kung magdiretso ka sa 2.5 ppm, dako ang error mo kay, diba, from 100, tapos timpla ka na yung 2.5 ppm. Ti ang sa imo na siya na pipiting, gamay lang na siya na error, dako-dako na siyang effect because you are basing it sa 100 ppm. So, mas mayo nga from 100, matimpla ka na isang 10 ppm, which is your intermediate solution. Okay. Pagkatapos nakatimpla ka na 10 ppm, no, halin sa 100 ppm. From the 10 ppm, it's now you make your 2.5 ppm, which is your working standard na amon na siya. Kay amon ni siya ang gamiton ta to generate your calibration graph. Okay, so Bisaya, ilongguhon ko na lang anay ha. So 2.5 ppm, halin sa 100, nag 10 ppm ta para less ang contamination, less ang error. Then from the 10, nagtimpla ta 2.5. Of course, ang inyo ang gamiton, volumetric pipette, volumetric flask. And very important, during the weighing ng chemical, dapat nakalibrate ang balance. Kaya diba, ang tanan ni error would start sa weighing, okay? Sala ang weighing mo, sala ni tanan. Okay, so calibration of the balance, or if it is already calibrated, you verify the calibration by using also calibrated and verified set of weights. So SOP gina siya if you are doing analytical measurements. Katidyos kaayo when you are in an analytical laboratory, damo sang himuon, dapat may pasensya ka as chemist because your goal is to generate an accurate and reliable result. So it all started sa equipment, calibration, using of the right glasswares, and also very important is also the right chemical. Okay, so balik na tadi. Okay, so this is potassium dihydrogen phosphate sa 2.5 ppm. From this 2.5 ppm, timpla naman kamo sa different concentrations. We have here 0.05, 0.1, 0.25, 0.5 ppm, 0.6, and 0.75. Then, i-read nyo nanda yun sa spectrophotometer. So, you must have at least 2 or 3 readings to get your final absorbance. Ang absorbance, amo na siya ang signal sa spectrophotometer. The higher the absorbance, the greater is the concentration of the chemical. So makita nyo na di, sa 0.05, ang absorbance na final is 0.033. So as the concentration increases, the absorbance reading also increases. Okay, so it's directly proportional. After that, i-graph nyo na dayon. So this is absorbance here, the y-axis, and the x-axis is the concentration. Sang imo na, amo ni siyang imo working standard. Next, so you have the concentration. After that, you graph no, the points. Then you check on the linearity no, using equation of the line, di ba? Y is equal to 0.062, mx minus b, which is your intercept. Familiar ka mo na sa linear equation. Then the regression should be near 1.99. Okay na acceptable, 0.98. Not so much, 0.995 acceptable ang linearity. After that, so y is your absorbance. M is your 0.629, kaya gin-compute na mo. Then X is your unknown na concentration, and B is your 0.608 is your intercept. Familiar ka mo ni sa equations ng line? Familiar ka mo? Familiar ka mo hindi? Kaya basi gahambal ako tapos hindi man ka mo gali kinshindi. Anyone? Okay. Hindi. Okay. Timayo kay kasabat. At least I know. So, okay. Anyway. Kung ara na binaplat na ang points, kwaon nyo na lang na siya ang equations namin. Kaya may-ari na dito sa Excel format. So, you have your formulas. Ay, sorry. Sorry, you get the slope. So, M, kaya di ba ang equation ng line is y is equal to mx plus b, which is your intercept. Ano na siya, di ba? Linear equation. So, y is, sorry, ang m, you get the slope is equal to, hindi siya mo ano, dapat rin na din sa stat, hindi siya mag ano, paano naman? Sorry. M is equal to, check nyo na lang di slope. Sorry, go to stat like that. Statistics. So you get the slope. Next, so known-wise, ang y nyo is the one, the absorbance. So known concentration, known x, equals to ang known x is ang x absorbance dali ang y din kanina. Y is equals to absorbance. Tapos ang x concentration. Amo na siya class. Ara lang man sa Excel. Done. Ang error na siya. Basta mo lang na siya mag-compute kay lawig paton lecture. Anyway, makadto man ta gyapon sa topic na sa standardizations gina-orient ko lang kamo. So amo na siya ang y is equal to mx plus b where your m is the slope. Si slope bala ni sang graph and b is the intercept. So pagkakuha nyo na sa equation na ni, then you have already your may sample na kamo wala kamo kabalo kung ano ang concentration. So analyze yun na siya the same way again process again check nyo ang inyong standard solutions. Kag here mera bitaw mo nakuha ang absorbance ng 0.25 example. So ang absorbance yun na diri nyo na ibutang sa y. No, y nga ka diba y is absorbance. So y is equal to 0.6292x minus ang slope, ang inyong intercept nga 0.008. So you can now get your x or your unknown. Okay? Amo na siya ang role sang standards, sang primary standard. Balik na to sa primary standard. Kalayo na sa ato nalaktan. Amo na siya ang role sang primary standard. This is used in calibration. This is your calibration curve, calibration graph, no, or calibration chart to compute kung ano ang concentrations ng unknown. Kaya di ba again, you have your y which is your absorbance times the slope, no, nga makuha nyo na sa computation, no? And then x is your concentration nga unknown minus ang b nga intercept. So makuha nyo na ang x, okay? Sang phosphate because no, ang inyong again gamit ang also ang primary standard containing phosphate. So you can use it in determining the unknown of your the unknown concentration no sang phosphate in your sample mo na siya. So in other words, ini siya ang ginagamit lang ni as reference para ma-compute yung ang unknown niyo. Okay? But again, I am highlighting to you nga dapat tsakto ged ang inyo nga preparation kay di ba amo ning basis ang unknown niyo mag-compute sang unknown. So what happens kung tiko tiko ang curve niyo? Meaning, you have to redo it again or pangitao nyo na kung diin ka mo ang error niyo nga nang tiko ang curve niyo or base ang inyong pagtimpla sang diri binagtiko pagtimpla sang sine na concentration basi nasubrahan yung dilute no naglapaw sa mark sa volumetric flash or basi wala ka mo naggamit volumetric flash no. Okay, so kansindi na kamo sindi kamo kainsindihan nyo na mabalik na to sa lecture ta. Sabat man kamo ko para makabalo ko nga naka-insindi ka mo. Okay, so next. Okay. Okay, so next, we are still in the basic tools and operations. Okay, let's go to the different review na lang ni actually because I know sa Chem nakuha nyo na yung iban. Tools in heating, evaporating solvent, removal, and refluxing liquid. So this is a porcelain or ceramic dish used to evaporate excess water. To ensure that a concentrated solution or the dissolved substance is left behind. What do you call this one? This is an open dish evaporating. So this is an evaporating dish used in open dish evaporation.
Excuse
Okay?
me, miss.
Yes.
Wala, may gagawa na
Wala.
slide, miss.
Dali
Oo.
lang. Okay na? Ara na?
Okay na, miss.
Okay, so this is an evaporating dish used in open dish evaporation. So examples of the test, no, using this one is the determination of total suspended solids in water. Suspended solids, di ba? So solids. Ang what is retained here is being measured after filtration. Next, we have the Florence flask. Take a look at the shape. This is used for heating substances that need to be heated evenly, mostly used in distillation experiments. So Florence flask. Okay, next, we are still in evaporating liquids. It is difficult to control the setup because of bumping. It can be minimized by careful and gentle heating and by the use of glass beads, glass beads, where permissible. So, hindi na sa buong class also ang alcohol lamp, di ba may hot plate na? Okay. Okay, these are the different heating apparatus. Okay, this one is of course no Bunsen burner. This is the hot plate, and steam bath. This one, may mga iron rings yung, mga rings para lang ma-fit ang ang ginahit niyo. Next, this is a heating mantle. And this one is a sand bath. May ara siya sand sa here. And this one is water bath, pero may hot plate, tapos may water, and you heat your solution in a water bath. No, depends on the procedure. And this is an oil bath. So of course, di ba ang oil bath, ang oil has a high boiling point. Next, heat gun. So we have here water baths heated on a hot plate are most commonly used to heat solutions to, wala na ni siya, 100 degrees Celsius lang. Next, okay, example of boiling bath. After that, mayroon man nga water bath to cool an apparatus after boiling. Now, this is heating a flask with a sand bath. Then, you just lift up the flask when you allow it to cool. Wala na ng isa ka 100 Celsius. Oil baths are like water baths but use silicone or mineral oil in order to enable the temperatures hotter than the boiling point of water, so greater than 100 degrees Celsius. It is also common for the oil to be electrically heated through immersion of a coiled wire connected to a variac. Amo ni siya tawag ni a variac. So of course, you have the wire gauze used with a ring clamp to support glasswares over a burner or even in a hot plate. Next, striker. Kita na mo sa striker. Used to light a gas burner. Then we have a crucible tongue used to hold crucibles and evaporating dishes when they are hot. Okay, so this one is a reflux apparatus. So there is a condenser. May condenser, pabalik-balik. So, ang difference nila sa distilling apparatus is that ara siya yung vertical ang iyang position while the distilling apparatus nagahilay siya or horizontal, di ba? So this is a reflux setup with the condenser returning to the original flask. It remains at the boiling point of the solvent. So one example of reflux method is the determination of chemical oxygen demand in wastewater. And this is the setup. We have here the water in, water out. Tapos nagbalik-balik lang di ang solvent. This is used as an extraction technique. Okay, so that's the setup. Pero hindi naman gets mong uso ang sunbath. Usually sa organic chem lab siya ginagamit. Now we also have a reduced pressure evaporation. So kinalandi ang vacuum pump. Evaporation can be accomplished from a solution quickly by placing it in a sidearm flask, sidearm flask, sealing the flask with a rubber stopper and applying vacuum siya. Thick black tube, vacuum tubing. Nara ang setup. So meron siya nga sidearm flask. Tawag siniinap lang do may connection di sa joint di siya sidearm flask tawag sina. Now next we have a rotary evaporator. Removes liquids, especially sa amon sa lab, we use it to remove alcohols from the extract. So in here, removes liquid from the preparations that need to be dry. So ini siya ang rotating flask diri na siya Okay, so this is the rotating flask and this is the water bath. Nag-rotate na siya, nag-rotate while separate ang alcohol. So example is ethyl alcohol from your extract. Separate. So ammonia siya ang receiver ang distillate which is your ethyl alcohol. So this is one good way of recycling. And diba, gina-reuse mo ang alcohol. Okay, whatever is being accumulated here na alcohol can be used as ginagamit naman as disinfectant sa microlab, no? Ang na-separate na alcohol from the solution. So this setup is a rotary evaporator. And this is the anatomy. So we have here the water bath temperature knob. Next, the rotating flask. Next here is the water bath. Then you have here the speed control, vacuum. Okay, so this is under controlled temperature and lower pressure than the para lang at least ma-recover mo ang alcohol efficiently or whatever liquid you want to separate. Reduce pressure. Amo ni siyang unit naman sa lab. Next, distillation. So notice the position of the condenser, no, in contrast with the reflux here. Na ang sa reflux siya vertical, ang sa distillation, and so with the rotary evaporator, it's slant or vertical. So it works well if the solution is composed of a solid and a low boiling solvent, or if the solution is composed of a high boiling liquid and a low boiling solvent. Okay. So next, we have the steam distillation. Itanawan nyo naman ang setup. This is used to distill compounds at temperature lower than the normal boiling point of water. So main conditions are observed to use steam distillation, extraction of temperature-sensitive compounds, inabalang mga essential oils, no? Example, makakamasa essential oil from leaf, no? Sa mga tanglad, when material to be extracted is immiscible and when the substance is chemically non-reactive with water. So, ano siya ang distillation. Next, we have fractional distillation, process by which components in chemical mixtures are separated into different parts called fractions according to their different boiling point. So, in sa mga petroleum companies. Okay, so what goes out first in fractional distillation is the gas. Then after that, gasoline. Next, kerosene. Next, diesel oil. And next, the fuel oil. And what remains here are the lubricating oil, the paraffin wax, and asphalt para sa lower na chamber. Okay, so for filtering non-gelatinous precipitates, we have filtering crucibles, Gooch crucible. Letter B, among sang tsura sang sintered glass crucible, and this one is the porcelain filtered crucible. So know the differences, no, sa tsura nila. Okay. And their uses too sa experiments na. So these are already very basic, you know, this one, review na lang. And this is drying oven, used to dry samples before weighing, usually at 105 to 110 Celsius temperature range. So ginagamit ni siya most often in the determination of moisture, no, in food or in any sample. But now, meron na sa moisture analyzers, so, pila lang ka minutes, may result ka na. So, ang purpose na lang of oven is for drying some samples, no, to speed up the analysis. Okay, so now we go to measuring mass. Okay, in most analysis, an analytical balance must be used to obtain highly accurate masses. Okay, can we, can we stop in here and then continue tomorrow? And then let's also discuss the format for writing lab reports. And after that, we also will discuss our first pre-lab na experiment. So, ang first step would be calibration of volumetric glasswares. After that, ano ba ito ng lesson? I know. Ang first tomorrow is that I will orient you, or a staff will orient you to the different equipment in the lab, sa lab namon, and then different glasswares commonly used, and which are also uncommon, no? Depende sa test na gina-perform. And also, next meeting, we will have calibrations of lab wares, no, volumetric wares, and then determination of alkalinity in water as part of the acid-base titration na experiment. Okay. Okay lang. We will start earlier tomorrow. Maybe, ano oras to? I-check ko lang ang schedule sa Zoom. Tomorrow we'll start at 1:30, probably 1:45. So, because we will wait for others to come in. Kaya ang iban, budlayan sila sa internet connections nila. Okay lang sa inyo. We'll start at 1:45. Sige, sige. So, this is all for today. And i-email ko lang to. Would you want it email or sa messenger na lang, no? Masapos ang lecture last week and earlier this afternoon. And probably sa next week, mga quiz ta. Okay lang? Okay, get in, no?